All right, welcome back, everyone. Today, we're tackling a pretty ambitious goal. In just about 3 minutes, we're going to completely map out a modern IP CCTV system architecture. And we're doing it strictly from a professional extra low voltage, or ELV, engineering standpoint. We're going to break down exactly how these systems are actually built in the real world. Think about it. You probably walked right past a camera today, right? But do you actually know what's going on behind the lens? What really makes it tick? Well, stick around because in this explainer, I'm promising to take you from an absolute beginner straight to a systems expert. Okay, let's dive right into this with Section 1, Modern IP CCTV Basics. First things first, let's get the acronym out of the way. CCTV literally stands for Closed Circuit Television. But here's the thing, its modern identity is all about privacy. We're talking about a completely closed video network that routes footage directly to specific recorders and monitors. It's totally walled off from the public internet, zero outside access. Now, back in the day, old analog CCTV basically just used passive lenses and centralized processing. Pretty basic stuff. But modern IP CCTV, it is a completely different beast. These are fully networked devices. Every single camera gets its own independent IP address. So essentially, they aren't just passive lenses anymore. They're basically tiny little computers that happen to have eyes. Moving right along to Section 2, the 5 core system components. All right, here are the 5 essential building blocks every ELV engineer absolutely needs to know. Number 1, IP cameras. And we're talking specific specs here. For indoor use, your baseline minimum is 4 megapixels, but at the entrances, you gotta bump that up to 8 megapixels with a wide dynamic range of over 120 decibels to handle that extreme lighting. Number 2, the PoE switch. Power over Ethernet is huge because one single cable carries both your data and your power, which completely eliminates the need for separate, clunky power supplies. Number 3, the NVR, or network video recorder, which manages and records all that footage. 4, your storage, which leans heavily on H.265 plus compression. And finally, number 5, the monitoring station, where operators actually watch the live feeds. So what does this all actually look like when you plug it in? Let's mentally wire this thing up right now. Picture this. Light enters the IP cameras, and those cameras instantly shoot that data down the line to the PoE switches. Those switches then route that data straight into the NVR. The NVR writes it all onto your RAID storage. And finally, the whole shebang pops up on a screen at the monitoring station in the control room. That's it. That is your exact, precise flow of data from the lens all the way to the operator. Which brings us to Section 3, Mandatory Engineering Rules. Okay, knowing the parts is great, but it's totally useless without the rules. Here are your 3 absolute non-negotiables. First up, ONVIF Profile S, G, and T. That is your gold standard for making sure different equipment brands can actually talk to each other. Second rule, H.265 plus compression. Listen, for any project with over 100 cameras, this is literally mandatory. Why? Because it radically cuts your storage footprint in half compared to the older H.264 standard. It's a massive money saver. And Rule 3, any external cameras you mount must, and I mean absolutely must, carry IP66 weatherproof and IK10 vandal-proof ratings. All right, let's scale this up. Section 4, Enterprise Scale Deployment, taking a look at a 5-star hotel. Let's start with a nice, big, round number, 800. For a massive hotel project, you're realistically looking at around 800 cameras spread out everywhere. Guest rooms, public areas, the back of the house, the perimeter, you name it. And as part of that master design, you've got to make sure those main entrances get specialized ANPR cameras specifically for capturing vehicle license plates. Now, to handle that massive constant influx of data and power coming from 800 distinct network devices, you're going to need roughly 60 dedicated PoE switches strategically scattered all throughout the network. And then you've got this requirement to think about. You're going to need 6 to 8 heavy-duty NVRs just to handle the load. But here's the absolute kicker. They must be set up in a failover configuration. That is absolutely crucial. It's how you guarantee continuous system reliability just in case one of your recorders suddenly decides to drop offline. No lost footage, ever. To really put this massive scale into perspective, here is your final metric. Just to meet the standard 30-day footage retention mandate for all those 800 cameras, you are looking at a staggering 200 terabytes of required storage. Seriously, sizing your storage correctly based on your camera count, your resolution, and those retention days, that will completely make or break your deployment. Finally, let's talk about the red tape. Section 5, Regional Compliance Standards. Please pay close attention here, guys, because skipping this step guarantees your project will fail at handover. You have to map your jurisdictions to the right regulatory bodies. For example, if you're working in Saudi Arabia, every single camera needs MOI approval. Building in Dubai, your system has to be SIRA compliant. And down in Abu Dhabi, you need SIRA plus ADMCC compliance. At the end of the day, technical perfection means literally nothing if you don't have that jurisdictional sign-off. So, what's the big takeaway from this explainer? It's simple. 5 components: your cameras, switches, NVR, storage, and monitoring. 3 rules: ONVIF interoperability, H.265 plus compression, and those rugged weatherproof ratings. And of course, total compliance. Always check your local jurisdiction first. Once you've got these basics locked down, you are ready for the big leagues. And actually, in our next explainer, we're going to dive right into exactly how to choose the perfect camera for every single type of space. And there you have it. That is your blueprint. Subscribe and build your ELV career right from the ground up. Keep learning, keep pushing the boundaries of your engineering knowledge. But before you go, ask yourself, is your current system design truly compliant, or are you just one tough inspection away from a total teardown? Think about it, and I'll catch you in the next explainer.